Alright, so this is our code. So in this file, this is our keypad.h file, where we have our defined variables and our function prototypes that we'll be using in our main keypad file. This is the keypad.c file. We have various functions that we define in the keypad configuration. We set up our STM32 board ports. So in this case, we're using the GPIO-E ports. We have our rows as our inputs and our columns as our outputs. For our inputs, we have a pull-down resistor to avoid any floating voltages. Our next function here is which key is pressed. So this sets all the rows. It sets all the columns as highs, and then checks individual rows to see which key is pressed. And then once it figures out which key is pressed, it will decode the specific column and row combination and return a key value. We have a function to determine if any keypad is pressed. And then our last function here is our debouncer, which calls is any key pressed 4 times that are spaced 100 microseconds apart to ensure that an actual press is registered. And then in our main file, we set up our GPIO ports for our LED, which will be our visual aid to see if our keypad is working. We have an infinite loop that checks if there's any press detected and debounce it, and if there is, we will light up the corresponding value on our LEDs, and that is the main part of our code.
Alright, so now for the hardware part, here are the connections. So we have our LEDs that it's basically the same connection as assignment 1, and then they have pull-down resistors, which are 560 ohms each, and we also have the external pull-down resistors for the keyboard, which are also 560. And just to demonstrate that our code is working, press 1, we get a 1, press 2, we get a 2, 3, 4, 5, 6, 7, 8, 9, is it here? 10, 11, 12, 13, 14, 15, and 0. Yeah, that's it.